Everyone, this is welcoming you to School of Chemistry, free chemistry summer tutorials. We hope to make this a coaching class where we'll be here together for a long time, not just after this class, we'll continue together. So stay tuned. But for the sake of this class, we're starting with the concept of the periodic table. Now, there were so many contributions to the concept of the periodic table, but the most important one is what we'll be taking. Mendeleev was the first to arrange elements into the periodic table. Dmitry Mendeleev is a Russian scientist. He arranged elements into the periodic table using the relative atomic mass. And when he used the relative atomic mass to arrange elements in the periodic table, he was able to show that certain properties reoccur at particular intervals. And for this table, there were some gaps. And using those properties, he was able to predict the properties of these very elements that were not discovered at this particular time. And over time, those elements were discovered and they fit in exactly to the description of Dmitry Mendeleev. And that is because there is a reoccurrence in property that was used for the prediction. One of those elements was germanium. He was able to predict it and it fit in exactly to the gap on the periodic table. We also have scandium and some other elements that were predicted. Now, advances in science and technology brought in the concept of the modern periodic table, and which we refer to as the periodic law. It follows what we call the periodic law. Now, what does the periodic law state? The periodic law states that the properties of elements are a periodic function of the atomic number. Properties of elements are what? A periodic function of their atomic number. So, when Mendeleev used the relative atomic mass in the arrangement of the periodic table, the modern periodic law uses the what? The relative, uses what? The atomic number. So this is the difference. And now, the use of the atomic number is not preferred for several reasons. And we'll be looking at is what the concept we'll be looking at in this particular course. Now, let's look at the concept of the electronic configuration and the periodic table. And the periodic table. Now, given an element X, we know that A stands for the atomic number, YZ, A stands for what? The mass number, YZ stands for the atomic number. This is the mass number, and this is what? The atomic number. Now, remember that the atomic number, what is the atomic number again? Atomic number is a number of protons in the nucleus of an atom. The numbers of protons in the nucleus of an atom is what makes up what? The atomic number. Now, in that nucleus, we have both the protons and the neutrons. So, the sum of the protons and the neutrons gives you what? The mass number A. And that means the atomic number plus neutron will give you what? The mass number, which is what? A. Now, in an electrically neutral atom, you know that the number of electrons is always equal to the number of protons. So if you have an element with atomic number A, it means atomic number 1, it means that it has 1 proton and 1 electron, if it is what? Neutral. From the Bohr's model of the atom, okay, proceed with that. So if you are given element, say Z with atomic number 20 and mass number 10, no, mass number 20 and atomic number 10, you should be able to tell us certain things from this information. You should be able to tell me that the number of protons is 10, the number of electrons is 10, and the mass number is 20. Now, how many neutrons are there? Because we know in a given atom, from the Bohr structure, we know that the atom consists of a dense nucleus, which consists of the protons and the neutrons, while electrons revolve around in circular orbits. So now, how many neutrons will be in this atom? We know all that. I just want us to have a recap of that since it's a revision class. Mass number is equal to number of protons plus number of neutrons. So neutrons will be equal to mass number minus what? Number of protons. So that since the mass number is 20, it's going to be 20 minus 10. And the number of neutrons will be equal to what? 10 neutrons. So that's how to calculate each of these variables in a given element. But that is not the bone of contention. Now, from the Bohr's models of the atom, it says it consists of a dense nucleus that houses the protons and the neutrons, with electrons revolving around in circular orbits. You call them circular orbits, or share, or energy level. Each of these orbits or share or energy level are placed at particular distance from the nucleus. A particular distance from the nucleus. And each distance represents a particular number, a particular amount of energy. And that's why we say it is quantized. When we look at quantum mechanics, you understand what we're talking about. Now, if you understand quantum or suborbitals very well, you know that each energy level has a particular amount of energy. So the share closest to the nucleus has the least amount of energy, followed by the second, third, and the fourth. So the first share is denoted as what? The K share. K. This is your L share, your M share, and the N share. Now, going by your energy SPDF sublevels, the K share will carry the 1s orbital. The L share carries the 2s and the 2p. The M share 3s, 3p, and 3d. And the N share 3s, 4s, 4p, 4d, and 4f. So this is how these things comes about. Now, K share represents energy level 1 and it has one sublevel, that is the 1s sublevel. L share represents energy level 2. It houses the S and the P sublevel. That's why I have 2S, 2P remaining, denoting that they are in the second energy level. You have the 3S, the 3P, and the 3D in the third sublevel, which is the M share. The M share has 4S, 4P, 4D, and 4F. Now, the maximum number of electrons that a share can carry is given by what? 2S squared. So if this is our share, and this is energy level, maximum number of electrons, which is 2s squared. So our K share, which represent energy level 1, we take 2, N is 1. So energy level is noted by N. N squared will be equal to 2. F share, energy level 2, going to be 2 into 2 squared. 2 squared is 4 times 2. It's going to be 8 electrons. M share, energy level 3, is going to be 2 into 3 squared. 3 squared is what? 9. 9 times 2, 18. Earth shell, energy level 4. It's going to be 2 into 4 squared. 4 squared is 16 times 2. That will be 32. So the K shell can take a maximum of 2 electrons. L shell, maximum of 8 electrons. M shell, maximum of 18 electrons. L shell, maximum of what? 32 electrons. Now remember, in the KMM configuration, the first shell here takes a maximum of 2, while the remaining shell takes a maximum of 8 electrons for convenience. Now in SPDF configuration, the S orbital takes a maximum of 2 electrons, the P maximum of 6, D maximum of 10, and F maximum of 14. So we'll be using this to write electronic configuration of different elements. If you are in the summer class, you have the notes. You have the notes and you'll be able to make reference. We'll text you of those elements, write the electronic configurations, and see how we can arrange elements and using the electronic configuration in the periodic table. So looking at the electronic configuration for some elements, let's look at hydrogen. Hydrogen has atomic number 1. So the electronic configuration, the first shell will take just 1 electron. In the SPDF method, we're going to have 1s1. Helium has atomic number 2. Still in the first shell, because the first shell can take a maximum of 8 electrons. So it's going to be 2 electrons there. And in the SPDF, we have 1s2. Lithium, 3. It's going to take a maximum of, first shell will take a maximum of 2 electrons, while the second shell will take a maximum of 1 electron. In the SPDF, we are going to have 1 S2, 2 S1. Now we have beryllium, 4. First shell will take a maximum of 2 electrons. The second shell will also take 2 electrons. 1, 2, 3, 1, 2, 3, 4. So we're going to have 1s2, 2s2. You must have known electronic configuration before. It's just a recap. If you don't know, we'll have to create a separate topic to discuss it. We have a boron, 5. It's going to be 1, 2, 1, 2, 3. This is 5. I'm going to minus this. SPDF now is going to be 1s2, 2s2, 2p1. Here I have a carbon, 6. So I'm going to have, will you take it? Let's do it here. 1, 1, 2, 1, 2, 1, 2, 3, 4, 5, 6. In the SPD, I have 1s2, 2s2, 2p2. Let's jump to fluorine. Fluorine, it's 7. Fluorine is 7. I'm going to have first shell is 2, second shell 1, 2, 1, 2, 1, 1, 2. No, fluorine is 9, not 7. Fluorine is 9. 1, 2, 3, 4, 5, 6, 7. Still need 2 electrons. 9. So here it's going to be 1s2, 2s2. There's no comma here. 2p3. No, 2p5. Am I correct? 2p5. I'm correct. Neon is 10. So we're going to have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So we have 1s2, 2s2, 2p6. Now we have sodium 11. 1, 2, 1, 2, 1, 2, 1, 2. That is 8. Then 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, the second share can take a maximum of 8 electrons. The first share 2 electrons. So here we're going to have 1s2, 2s2, 2p6, 3x1. Magnesium 12. We're going to have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's magnesium 12. Here it's going to be 1s2, 2s2, 2p6, 3s2. That is for magnesium. Then we have aluminium 13. Aluminium 13 will be 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That is 10. 1, 2, 3. So in next PDF now we have 1, 2, 2s2, 2p6, 3s2, 3p1. We are going to jump now. Let's do for chlorine. Chlorine is 17. Chlorine 17. I have 1, 1, 2, 1, 2, 1, 2. That's 10. I'm left with 7. 1, 2, 3, 4, 7. 1, 2, 3, 4, 5, 6, 7. That's chlorine. In the SPD, I'm going to have 1s2, 2s2, 2p6, 3s2, 3p5. We have argon 18. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is argon. And here will be 1s2, 2s2, 2p6, 3s2, 3p6. We have potassium. Potassium is 19. So we're going to have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That is 10. Space with DB enough. Please manage the 1, 2, 3, 4, 5, 6, 7, 8. That is 18. We are left with 1. The 1 will be in this shell. So in the SPD, we are going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4x1. Let's do for calcium, then we'll arrange them in the periodic table. That's what I want us to do. Calcium is 20. So we're going to have, calcium is 20, we're going to have, excuse me, let me clean the board. We're going to have first share 1, 2, second share 1, 2, 3, 4, 5, 6, 7, 8. third share, 1, 2, 3, 4, 5, 6, 7, 8. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And we have 28, so the second share will take 2 electrons. So they're going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And that's the configuration for cation. Now we're going to arrange these elements into the periodic table. Now, the periodic table is classified into groups and period. We have 8 vertical columns. 8 vertical columns called groups, and 7 horizontal rows called periods. Now the question is, what determines the group and what determines the period? And what we use in arranging all these elements into the periodic table. And that's why you must know your electronic configuration. You must know your electronic configuration very well. You must know which one determines the group and which one determines the period. If you don't know that, you may be having a whole lot of problem. So from the configuration we have done, you must know that for hydrogen, this is the configuration. The rule, first shade takes a maximum of 2 electrons, other shade takes 8. Why? In the SPDF, the suborbitals, we have said that the S orbital takes a maximum of 2, P maximum of 6, D maximum of 10, F maximum of 14. Now, what determines, okay, we say the periodic table has 8 columns. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8. Let's count. Some authors use number from 1 to 8, while others use from 1 to 7 and 0, or from 0 to 7. So this is going to be group 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 groups. So I'll call this 0 rather. It's more convenient for me. These are the 8 groups. The 8 groups. Now, the 7 periods, I'll start from here. At the horizontal row, 1, 2, 3, 4, 5. We have 6. That's the much we can take here. We won't be needing all of them now. But for understanding sake, this is 1, 2, 3, 4, 5, 6. So now, we say what determines the group and elements belong to is the number of electrons in the outermost shell. That is the valence electron. The number of electrons you have in the outermost shell will determine the group you place an element. And while the number of shells or the highest energy level that carries the electron in a given electronic configuration of an atom will determine what? The period. The number of shells or the number of energy levels in the configuration of the atom, of the element, determines the period. So if I have 1 electron in my outermost shell, and I have 1 shell, it means I'm in group 1, period 1. But if I have 1 electron in the outermost shell, and I have 2 shells, I'm in group 1, period 2. You understand? Now, so now let's use this electronic configuration to arrange these elements. 1, hydrogen. This is the configuration for hydrogen. It has 1 electron and 1 shell. Remember, the electron in the outermost shell will determine the period, while the number of shells will determine the group. Now, in the SPDF configuration, the highest number, that is the energy level here, tells you the period, while the valence electrons here tells you the group. So here now I have 1 electron in the outermost shell, 1 electron in the outermost shell, 1 shell, period 1, 1 shell, period 1. So hydrogen is going to be in group 1, period 1. Helium. Helium has 2 electrons in the outermost shell, S2, 1 shell, period 1. Now you can place helium, for convenience, helium is placed in period 0. Why? Because it has the chemical properties of the noble gases, which are in group 8. But you can also place helium in period 2, group 1, by this formula, because it has 2 electrons in the outermost shell and what? 1 shell. Period 1, group 2. That's why in some periodic table you see it in group 2, others you see it in what? Group 8. Lithium. Lithium has 1 electron in the outermost shell. So it's in group 1. But it has what? 2 shell. It's in period what? 2. Look at it now. 1, 2, this is the highest number, so it's in period 2. And that period 2 now has 1 electron in the outermost shell. So this is 1, group 1, period 2. So this is going to be lithium in group 1, period 2. Beryllium, 2 electrons in the outermost shell. That is beryllium, 2 electrons in the outermost shell, but 2 shells, 1, 2. 2, period 2, 2 electrons in the outermost shell. So it's going to be in group 2 because it has 2 electrons in the outermost shell. Look at it here, 1, 2. 2 electrons in the outermost shell, period 2. This is going to be what? Beryllium. Now, boron, 3 electrons in the outermost shell, 1, 2, 3. And 2 shells, 1, 2. So boron is going to be 1, 2, 3, group 3. 1, 2, period 2. So here it's going to be boron. Group 3, period 2. Fluorine, 1, 2, 3, 4, 5, 6, 7. 7 electrons in the outermost shell. Group 7, 1, 2. 2 shells, period 2. Let's use this formula and see how you get it. Highest number is what? 1, 2. So it's in period 2. How many electrons are in that energy level? We have 2 plus 5, that is 7. So this is group 7, period 2. So our fluorine is going to be here. Carbon. Okay, we'll jump carbon. Carbon, 4 electrons in the outermost shell. 1, 2, 3, 4. 2 shells. 2 shells is period 2. 4 electrons in the outermost shell is group 4. So this is going to be carbon. Yeah, this is carbon. We have neon. Neon, 8 electrons in the outermost shell and 2 shells. 2 plus 6, 8. Highest number is 2. That is period 2. This is going to be what? Neon. Then we have sodium. 1 electron in the outermost shell, 3 shells. 1, 2, 3. Look at the highest number here. This is period 3. Group 1, 1 electron in that highest shell. Energy level. This number determines the highest energy level in this system. We have 1, 2, 3. So this highest energy level carries the valence shell, which is 1. So it's going to be 3, group 1. This is what? Sodium. Then we have magnesium. 2 electrons in the outermost shell, group 2. How many shells? 1, 2, 3. We're going to have magnesium here. Then we have aluminium. 1, 2, 3. Group 3. Because 3 electrons in the outermost shell. 1, 2, 3. Period 3. Look at it here. Period 3. The highest number energy level here is what? Number n is equals to 3. So it's going to be 2 plus 1. Group 3. So here it's going to be aluminium. Followed by what? What do we have here? Chlorine. Chlorine has, look at the highest number for chlorine configuration. Energy level 3. That is the valence shell. 2 plus this is 7. So period 3, group 7. Count the valence electrons. 1, 2, 3, 4, 5, 6, 7. 7 valence electrons tells you the group you belong to. The period will be determined by the number of shells. 1, 2, 3. Period 3. So we're going to have group 7, period 3. Chlorine. Now we have, after chlorine we have argon. Let's count the number of valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Group 8, number of shells. 1, 2, 3. So the number of shells determines the period. So it's going to be 1, 2, 3, period 3. The number of electrons in the outermost shell determines the group. 1, 2, 3, 4, 5, 6, 7, 8. Group 8. This is what? Argon. Now we have potassium. Potassium is, number of electrons in the outermost shell is 1 here. Look at the highest energy level, which is 4, has 1 electrons in the outermost shell. So it's going to be in group 1. Valence electron, number of electrons in the outermost shell determines the group. Why? The number of shells or the highest energy level determines the period. So 4 here, which is 4 shells, 1, 2, 3, 4, is going to be period 4, and the number of electrons in that outermost shell is 1. So here is going to be potassium. Calcium. the group will determine that the number of electrons in the outermost shell, 1, 2. So it's going to be group 2. The energy level, which is the number of shells, 1, 2, 3, 4. Look at 4 here. Period 4. Number of electrons in the outermost shell, 2. That means it's going to be in group 2, period 4. 1, 2, 3, 4. This is period 4, group 2. We have what? Calcium. So that is how to arrange elements in what? The periodic table. Now remember, in your periodic table, the standard periodic table, between group 2 and group 3, we have the what? The transition metals. Now, if you look at the configuration we have done so far, from what we have done so far, elements in group 1 and 2 have their valence electron in the s orbital, so we'll call them the s block elements. While elements from group 3 to group 3 to 8 have the elements in the p orbital, I'll call them the p block elements. Then we'll have the transition metal between group 2 and 3. Transition metal between group 3 having the elements in the d orbital, I'll call them the d block element. And then the lanthanides and the alkanides have their valence electrons in the f orbital, I'll call them the f block element. Now, certain things you need to know from this periodic table. When we start discussing chemical combination, you will learn that it is from these valences that determine the chemical properties of this substance. The number of electrons you have in your outermost shell will determine whether you are a metal or a metal. A metal can give out electrons, while non-metals can what? Receive what? Electrons. So, majorly group elements to be labs, that is group 1 and 2, are metal, which are the alkali and the alkaline metals, while there is a boundary in between group 3 and 4 of metals, semi-metals, and non-metals. But elements on the left generally are metals, while elements on the right of the periodic tables are non-metals. Please, if you have a question, do not forget to leave it in the comment section. Subscribe to the channel and keep following us. If you have not joined our community, join our WhatsApp group with the link in the Facebook. Welcome to School of Chemistry.